Hi, sir.
Hi, Amy. How are you doing?
I'm good, thank you. How are you?
Very good, very good. So we have been talking about trigonometric functions, sinusoidal functions to be very specific.
Yeah,
We did touch upon the graph of tangent ratio also, right?
right.
So did you understand all these graphs of sinusoidal functions and the tangent?
So yeah, I understood the ones that we went through lesson and just kind of the basic ones of drawing tan, because that was my main issue, tan. And so I got that. It's just when it came to the transformations, just sketching them, I can't seem to get my head around. And I feel like there's some little, because I understand the stuff, it's just not coming when I'm doing the questions. So do you think we could just quickly run through a
Sure,
couple?
sure. No problems, no
Yeah.
problem. You can
Can I
share
just
whatever questions you have. So yeah, you have an access to that. So you can just share whatever you have.
Perfect. So yeah, 6 made sense because that's kind of what we did through in lesson, just
Yeah,
going through the
0 to
basics.
2 pi. 0 to 2 pi means how many cycles for 10? Can you tell me?
So 2.
2 cycles, correct? Because
Yeah.
the period of pi, correct?
180, yeah, is the normal.
Yeah.
Sorry, I'm getting used to the radians. Yeah, radian. I'm talking radians now just to get a bit more familiar with it.
Okay, so good. 6
Yeah.
is done. How about 7?
Yeah, that's the issue. So 7 and 8. So can I just quickly run through what I did and then see where I went wrong?
Yeah.
So with the sine x, so I started off just doing the basic parent function, which is the y equals sine x, and then did it within the boundary using both methods, just like graphically doing it, and then I wrote the coordinates of the 5 key points. And then because the transformation is minus pi, I know that you're moving it right pi units, so in degrees, just 180 degrees to the left. So every coordinate would move like that. But when I did that, I found that some of the coordinates don't fit the boundary or that restriction that's given there. So do I change the restriction, and then how would the graph look roughly? You don't need to go through all of them, just one of them, just so I can kind of get the hang of it, and then I can maybe do the others.
Okay, so can you please read the question?
Yeah, so sketch the following graphs for the given ranges, marking any points where the graphs cut the coordinate axis. So A, y equals sine x minus pi for x in between minus pi and pi.
Okay, so for my other listeners, let me make few points very clear. Because the language which you use is very tricky. You use the word ranges, correct? So please, can you read this statement once again for what is it written?
Sketch the following graphs for the given ranges.
So when normally a student gets this word ranges, it seems as if it is along the y-axis, correct? But it's not that. Range within the domain, that is what is meant, right? So the variation in the x value. So within the given ranges. So for A, which you really want, is y equals to sine of x minus pi, where x is between minus pi to plus pi. So within that, I should say domain now for my other students globally. They understand the word domain better. So within this range of the domain from minus pi to pi, we have to sketch the graph of sine of x minus pi. Is this clear to you?
Yeah.
So now, let me give you a very rough okay.
Would you like me to zoom out so you have some space?
Yeah, because I don't have space. Or I will actually get into a whiteboard to sketch it for you. That'll be better for me, right?
Okay.
Since I have very less space to work here. So, so if you could exit from here, from your sharing, okay, then I will share whiteboard. It'll be easier for me.
Yeah, I've got the question here if you want to.
Yeah, I kind of remember. So we'll just.
Okay.
So we have this white. So let me just write down the question here. We have sine of
x minus pi.
X minus pi, correct? And we're talking about the domain where x is between
minus pi and pi.
Minus pi to plus pi. This is the question. Let's broadly understand the question. So what I will do here is I normally draw the axis later, sketch the graph first. So it becomes easier to fit in the graph on the axis. You get the idea. I do the reverse,
Yeah.
right? I like that approach. So the sine curve is a very beautiful curve, right? I love this curve. Clean.
Yeah.
Now, there is no horizontal, I mean, vertical shift, and the amplitude is also one, correct? So
Right.
clearly, what I have here is we are kind of sketching it, right? So do you
Yeah.
see? I'm just drawing a line here. So that becomes my x-axis. Is that clear to you?
Yeah.
Where did it go? Okay, there we go. So that's my x-axis. Now, the idea here is that, as you rightly said, we have shifted the sine graph pi right, correct? So you could assume that earlier the sine graph will start from, let's just use some other ink, right? Let us say the sine graph starts from, let's say starts from here, correct?
Yeah.
And what you did, and this is my actually sine x. Let me say sine x. Then sine x was like this. That is a period of 2 pi. Since we shifted the maximum, we shifted right by pi, right? We shifted, this is, let us say this is 0. And this is 2 pi. We are going through the thinking process at present. I'm not sketching,
Yeah.
I'm just explaining. So this is pi, correct? So what really happened when we have sketched the graph of x minus pi, the graph moved, and then let me now sketch this transform function. And so it starts from here. It kind of flips. Do you see that? It kind of flips. You see that? So it starts from here. Do you see that?
Mm.
So now actually it starts with pi. So this is the graph which you're talking about. Is this clear to you?
Yeah,
So in
because
your
we had 0, 0 before, and then shifting it pi units. Now we've got pi 0.
correct. So we shifted this to pi. You see that you
Yeah.
see this pi. So
So
basically,
every other point did it as well. Yeah.
yeah. Now you should remember one thing. You only want to sketch not the graph which I have sketched. I have sketched the graph from pi to 3 pi. You can say that, right? This is
Yeah.
pi, 2 pi, this will be 3 pi. Is that clear to you?
Mm-hmm.
I have sketched a graph from pi to 3 pi. Correct? Now, what basically has happened is we only want the graph between minus pi to pi. This is what we need, correct? So basically,
Yeah.
you have to see the other half, which is on this side. Is that clear to you? So you have to
Oh.
actually start from this side, which is minus pi, correct?
Yeah.
Minus pi, correct? So so if you do that, I mean, you get the idea what I'm trying to say, correct?
Yeah. Yeah.
So now let me, because we have understood the whole story about it, what we can do here is that we can say, well, strictly speaking, if I move that scale, then what really happens is that I will have a graph kind of like this. Do you see this?
Mm-hmm.
But that point will become minus pi. I mean, this is, I don't have space here. So if I go here, I mean, if I extend this blue graph here, what do I see? I see something
Minus
like this
pi.
only, right? I see something like this only. Is that okay?
Yeah.
Because it is periodic, correct?
Right. Right.
So therefore, what will I do here in the test is I will actually sketch my y-axis right here, x-axis right there. I will mark this point as minus pi, this as 0, and that as pi. And that is my graph. Did I make sense to you?
Mm-hmm. Yeah.
Let me do it once again so that I'll clear everything now. Now think fresh, okay?
Okay.
So I'll make slightly smaller so that I can show you both the parts, right? So we are
Okay.
trying to sketch the function which is sine of x minus pi, and we are interested in the value of x between minus pi and plus pi, correct?
Yeah.
So what we basically started with is the sine graph itself, which let me show this time in a very light color and smaller wave. So, oh, sorry. Okay, undo. So when I sketch the sine graph, I also draw lines. You must have seen maximum, correct?
Yeah.
and the minimum. So within these lines, because amplitude is 1, we are going to sketch the sine graph. Is that clear to you?
Yeah.
That's the axis, x-axis. So I'll make a smaller graph. I mean, not wide. Last time I had a very wide ones, right? So in which I'll have many waves, correct?
Yeah.
Perfect. Now, since I know I'm actually interested in minus pi to pi, I wrote just one. Minus pi to pi. So I mean, I have to keep that frame within my mind, right? So normal sine graph will be kind of, you can say that my x-axis will be here, y-axis will be here. I'll make this as my origin, right?
Yeah.
So the graph which I have plotted is sine x. No transformation, just sine x. So in this particular graph, sine x, the values which I have on my coordinate are 0. This one is pi. This is 2 pi, correct? One wave, correct? 3 pi.
Yeah.
Similarly, I have minus pi and minus 2 pi. Is this clear to you? Now, since you will prefer to go with my strategy of sketching sine of x minus pi as a transformed graph, which is pi units right?
Yeah.
So we'll just sketch one wave. We are moving this point 1 unit right, so it goes there, correct? This point 1 unit right, this goes there, 1 unit right, and so 1 unit right. So it will end, you can see instead of at 2 pi, the graph will start at pi, go to the maximum, come to the minimum, go to the, 0 axis and go to the 0, right? So we have a graph which is kind of like this. This is my graph, which is sine of x minus pi, correct?
However, just before we continue, sorry. So when you choose the points to move, does the points you choose have to fit in that domain, or does it matter what points you choose?
No, I'm saying at present, just general. I'm not fitting it in that domain. So I just drew my graph, correct?
Yeah.
Now I notice that we have to only sketch within minus pi to pi, not in the domain which I am creating.
Yeah.
Okay, then I will extend my graph to this domain. So I get my graph, let me put it in darker green color, which is required. You get the idea. So this graph, which is extension, since it is periodic, I now have a graph which is required in the particular domain. Is this clear to you?
I see. It's only clear when you lay it out like that. Yeah.
So I don't want to mix up what I've already taught you to what the question is, correct? So it is like this. Now, you should also remember that the graph is periodic, correct? So what you could have also done is that when you got these transformed points, because you could sketch it with the values also, right? So for sine x, you have your key points, which you know are 0, 0, right?
Yeah.
And then we have pi by 2, 1, right? And then pi 0, right? And then we have 3 pi by 2 minus 1 and 2 pi, correct?
0.
So those are your key points. Now, when you do this on sine of x minus pi, right, that could be a part of the question. What will be the transfer points? It is only shifting right. Therefore, the x values will be added up by pi, right? So we get 0 pi, and then you get 3 pi by 2. Pi could be thought as 2 pi by 2, right?
Yeah.
Pi by 2. So it's easy to calculate, right? 3 pi by 2, 1, correct? 2 pi 0, and then 5 pi by 2 minus 1 and 3 pi 0, correct? So that is the graph which I got when I showed you here, right? Do you see that graph? Those 5 points are these 5 points, correct? Now we also know that the time period is 2 pi, correct? Time period is 2 pi, right? We have landed at pi to begin with, correct? We want to go to minus pi. How do we go to minus pi? I have to shift my graph by 2 pi left, right? So I have to go left 2 pi, right? So I'll do minus 2 pi. Is it correct? To go in the domain from minus pi to pi,
yeah,
I am in the domain from pi. This domain is from pi to 3 pi. Is that clear to you?
Yeah.
So if I have to change from pi to minus pi, I have to do what? I have to do minus 2 pi, correct?
Oh.
It is a periodic function. 2 pi is the period, no problems. I just shift it. I'll do minus 2 pi to everything, right? So if I do minus 2 pi here, I get minus pi 0, correct? I'm just doing minus 2 pi, right? So I get pi 1. I get 0, 0, correct? I get, if I take away 2 pi from it, 4 minus this is pi by, what do you get? Pi by 2 minus 2 pi means 4 pi by 2. So pi by 2, right? Pi 0.
Yeah.
Pi minus 1, sorry. Minus 1 it is, right? And then, no, this is pi by 2. And pi, I take minus pi here, 0. Is that clear?
0. Yeah.
You just do minus 2 pi with your x values. It's not changing the y value, since it is a horizontal translation. Then you get the final graph, which is this particular graph. Do you see that?
Yeah, got it. So I did up to where you said, so all the coordinate points that you got for sine x minus pi, I got all those points, but I didn't realize they were in the domain from pi to 3 pi. So I did realize that, but I didn't know how to shift it to the right domain. So all I needed to do was the minus 2 pi. Yeah. Okay.
Minus.
Got it.
Good.
Yeah.
So then you get this graph. Now, the thing is, it is not necessary for you to do step number 2 and then get to the step number 3. Remember that part, right?
Okay.
Since we want the domain from minus pi to 2 pi, what really we could have done is
directly.
We, instead of starting from we actually took the wave from 0 to 2 pi, correct?
Yeah.
And we want, after transformation, the wave to start from minus pi. I could have started with the wave from
minus 2 pi.
Minus 2 pi.
I did think that, but I wasn't sure if you could do that. That's why I was asking. So when you choose the points that you want to move, can it be any of the points, or should you look at the restriction first?
So that you get to the point where you want to be.
First time, yeah.
So then you start with minus 2 pi one wave. Periodic. You get my point?
Yeah, and then when you plus 1.
So my rough sketch actually helps because it makes sense. So I have some freedom here, right? So I say, well, I want to be there at minus pi after moving pi units right. That means I have to start with minus 2 pi. It's periodic. Right. Wherever minus 2 pi is, I'll mark that point. And these are my 5 points to work with. Once I have these 5 points, I'll just move them and get a new point. You get the idea, right?
So clear, yeah. So I think what I didn't do was I did the sketch, but only for this side of it. I didn't do the back, so I got all flustered. So yeah, the point is just draw a rough sketch that kind of for like many waves, and then you draw your axes in. Don't like draw the axes first. So I think that's where I kind of messed up. Okay.
So make a rough sketch. It takes a minute, extra minute. I'm saying it takes extra 1 minute, but saves 5 minutes.
Yeah, and gets you like 10 marks. So it's definitely worth it.
So you start your wave, just show your transformation. Start at minus 2 pi, move pi units to the right. You are from minus pi to pi, you're done. Okay. Because I could have given the scale as like minus 4 pi, then what? I will keep on showing it. I will not have on the scale. You get the idea. I will not make my y-axis anywhere. I will just begin from any point here and I'll say, well, this is my minus 4 pi. And then I'll shift it. How does it matter? You get the idea.
Yeah,
I don't have to show my y-axis so much. I'm just showing my points as this is like whatever y value is 1. Do you see that?
Yeah.
I'm saying this is y equals to 1 and this is y equals to minus 1. This is y equals to 0. I'm done.
Oh, yeah.
So this frame helps you to actually provide very accurate result. Showing 5 key points accurately is what we are looking for.
Right.
Does make sense?
Yes. Yeah. Could I just take a picture of that? Just quickly.
Yeah, sure. So there are a lot of strategies going on here, right?
So the graphical rough sketch, and also you showed me with the coordinate points, just in case not that the graph wouldn't work, but it would.
No,
but
coordinate points accuracy. It is good to see that.
It's good. It's good to see both. Yeah.
So,
so I think I can answer the other questions of that part 7 now that I've seen what you've shown me on how to do.
If there's any difficulty, don't hesitate. Okay, don't hesitate.
All right, thanks, sir. And just last one would be 8.
Yeah. Now you can share that question again. I don't know what that question was.
Yeah, no worries.
Yeah.
So yeah, this one. Let me see if I can make it bigger. This one.
Okay. Yeah. What is the question? Please read the question number 8.
Yeah, so the diagram shows the curve with equation y equals cos x minus 2 pi over 3, where x is in between minus 2 pi and 2 pi, both included.
Very good. Both included, right? So somewhere on the scale, you have minus 2 pi to 2 pi, right?
Right.
And the graph has shifted 2 pi by 3 to the right. Okay? Can you enlarge this a bit more?
Yeah.
Okay.
So the question is to write down the coordinates of the points.
We'll figure out the coordinates. Correct. So that's, I think, perfect. So when you're given this, you know that the movement is 2 pi. Oh, let me just wait.
Is it big enough, or do you want?
I think this is okay. Yeah. 2 pi by 3, right. Is that okay?
Yeah.
Okay. When we are talking about the cosine function, let's be very clear, it starts with maximum. Is that clear to you?
Mm-hmm.
So those are the points which we are looking at. Those are the 5 points which we are looking at, correct?
Yeah.
Let me draw the axis here. We have very limited space, so I'm just looking at one way, right?
Yeah.
When they say minus 2 pi to 2 pi, they're talking about how many ways? Because it says minus 2 pi to 2 pi or 0. Can I see what this is they're saying? Minus 2 pi to 2 pi, right? So that means 2 pi means 2 waves. Do you see that? Okay. Now let's get back to the question. Yeah. So they are talking about, they're saying 2 waves, right?
Yeah.
So basically, we'll work with 1 wave. Don't worry.
Yeah, but in my head I know it's V2.
Yeah. They are saying a domain of two waves.
All right.
Important, right? Okay. Now we have shifted 2 pi by 3 to the right. It really means, and they are interested in coordinate points. Wherever the curve meets the coordinate axis means both x and y. So you have to give answers for these points. What are these points? Don't miss the y-intercept.
Mm-hmm. It's quite easy to do that because you're so focused on the x-axis stuff. Yeah.
Why? Yeah, you miss. Many students will miss y. They will only focus on that. No, come on. You cannot do that. Okay. So now, x-intercepts. All the x-intercepts move 2 pi by 3 right. That is what we have. Is that clear to you? Let's look at the first x-intercept, which is right there originally. What is the value of this x-intercept? It is
90
pi
over 2.
Pi by 2, correct? So when you add this pi by 2 by 2 pi by 3, what do you get?
A value.
Okay. So you have to take a common denominator, which is 6. Then 3 pi,
back to the basics,
complete way. 3 pi
3
plus
pi
4
plus 4 pi, 7 pi, over 6.
So the value moved to 7 pi by 6.
Yeah.
So that clearly shows that one of the points here is 7 pi by 6.
Is it that one?
Okay, 7 pi by 6 is more than a pi. 7 pi by 6 is more than a pi, and the time period here is only 2 pi. So if you look from maximum to maximum, this interval is basically kind of only 2 pi, right? So it seems if you are actually having it, this point will be 7 pi by 6. Because 7 pi by 6 is more than a pi, correct? 7 pi by 6 is more than a pi. And the time period here is only 2 pi. So if you look from maximum to maximum, this interval is basically kind of only 2 pi, right? So it seems if you are actually having it, this point will be 7 pi by 6. Because 7 pi by 6 is more than a pi, correct? So if you have a wave which is distributed, I mean, here, that means clearly that point cannot be more than pi. Do you understand? Because this is more shifted to the left. The section which they have shown you is very tricky. So, so your pi value is definitely less than this value. So 7 pi by 6 is on the right.
Yeah. Do you think I could visualize it like this, or would it be inaccurate? So you know where you like the curve's already drawn. You know that point that is literally right after so where the origin is, the point literally after that. Yeah, that point. Can I imagine that as if it was cos x, that as 0, and now if that's the point that's moved, it can only be the next x interception, so it has to be the one in the end.
But you don't know that point because the scale doesn't write anything. You don't know that point. We have to find that point. So we'll find it. So we got this point as 7 pi by 6. You get the idea?
Yeah, yeah.
Now the thing is that the time period is 2 pi. As far as the wave is concerned, every odd multiple means the distance between the x-intercept is pi, correct?
Yeah.
So I have to subtract pi to get the other points. So if I do minus pi, so 7 pi by 6 minus pi will be what? So that is 6 pi by 6, right?
Yeah.
Common denominator.
So pi over 6.
Pi by 6. So we got this point as pi by 6. Do you see that? Now again,
minus pi.
Yeah, we have to do minus pi. So we did minus because the time period, the period between the two intercepts is pi. So we have to take away pi, right?
Yeah.
We started with 7 pi by 6. Take away pi gives us pi by 6. Is that clear? So we got this point as pi by 6. Now again take away pi from here. Go left. So if you take away pi from pi by 6, what do you get?
Minus 5.
Minus
6,
5.
Yeah.
Again take away pi from here, right? So
minus pi.
Minus 11 pi by 6.
Yeah.
So when I say take away pi, it means minus 6 pi by 6, correct? So because you see how easily we got all the points.
Yeah, I thought you were going to, see, this is, so you did it so easily, but you know, when we first started, you just chose the point on the cos x curve, pi over 2. And I thought for each one, you were going to choose a point. And I was like, that's going to take me forever because I don't know which one it is. Yes. So yeah, that's easy because I know the interval between each of those thing is pi. So that's so easy. Yeah.
Got it. So we have now this thing here, right? When you say 2 pi, converting in terms of pi by 6, it really means minus 12 pi by 6. Does it make sense to you? We are at minus 11 pi by 6. So that point is correct.
Oh.
So you can check whether you are in domain or you have to add or subtract. I mean, sometimes you may think the starting point is not there, but it is here, correct? And in that case, you will land up at a point which is not in your domain.
Right, right.
So you have to see it very clearly, right? When I say minus and you're looking at divide by 6, let us think like minus 12 pi by 6. Is that okay?
Yeah, yeah.
12 pi by 6. Why not? And
it's because we're thinking it without the 6.
This is what I want, right? So where am I? Am I within this? Yes, I am. I'm done.
Oh. And we know that the two of those just be minus 1 and 1 because there hasn't been any vertical stretches in the equation. It's only been horizontal.
Correct. So when I talk about the x-intercepts, we know that the y values are zeros. Now, the idea is to get this particular y-intercept where x is 0, correct?
Do you just sub it in?
Sub in. And
so x is 0. Oh.
Sub in. And then you get minus 2 pi by 3, find the value, and then pi by 3 is the easy value, right? So because, you know, we are 30, 60, 90, pi by 3 triangle. Is that okay? We're looking into this particular thing where this is pi by 3. You get the idea, right? The sides are 1, 2 square root 3, correct? And cos pi by, so that is it, right? So, but it says minus 2 pi by 3, very 3. You could use your calculator. You could use your calculator.
Okay, I have it here.
So don't worry about it. So you'll get square root 3 over 2 as your answer, minus, right? So you know this is a negative value. Yeah, just calculate. Tell me, what do you get?
Oh, so just cos of minus 2 pi over 3.
Which is minus cos pi by 6.
Minus a half.
So you put that value. So when you put this cos of minus 2 pi by 3, put this value as minus half. So graph is not to the scale. It is very dicey graph.
Yeah.
You get the idea? So basically, look here. So we are talking about 1 pi by 3, 2 pi by 3. So when we say minus 2 pi by 3, so we are basically looking into this quadrant, correct?
Yeah.
So in which, let me just do pi by 1 pi by 3, 2 pi by 3, correct? In this quadrant, we are looking into this 1 over 2, but because we are in quadrant 3, it has to be negative value. And the graph also shows that. Is that clear to you?
Yeah.
So you can get your y-intercept also.
Yeah. So if I ever come across something like this, I just immediately go to the parent function, which is cos x, find the 5 key points, and then because I know that there's an intersection that comes after the origin, let's just start with pi over 2 and then just work from there.
Yeah.
Okay.
Correct.
Because I was finding that hard. I was like, how am I supposed to know the coordinates on the original to figure out how many units I added 2 pi over 3 to get the coordinates that are shown on that graph? So
now, let's change this question. Let us say you start with pi by 2 and you came up with the first result.
So I just checked the answers and they're all right.
Yes, they are right. Okay, good.
Yeah, I just wanted to reassure you. I know you know, but I thought
yeah, that's good. Now, what I'm trying to say is, I'm changing my question, right? I'm saying that I have the same equation, which is y equals to cos x minus 2 pi by 3, right? However, I'm changing this domain and I'm making this domain, instead of minus 2 pi to 2 pi, I'm making it minus 4 pi to minus 2 pi.
Okay.
You get the idea? I'm making it minus 4 pi to minus 2 pi. And therefore, the very first point which I get using all my calculations is not within the domain.
Yeah.
Keep on doing minus pi, minus pi, minus pi, minus pi. Till you come within the domain. Why not?
Right. Okay, got you. Yeah.
N multiples of pi. You have to take it.
And that'll be so easy because I've obviously had the calculator. I can easily do it.
You have one value, right? If you have one value, doesn't matter this value is here. Doesn't matter.
Yeah. You just minus 5. Until you get into the domain. Got it. Wow.
Until it comes within the domain. You get the idea.
Yeah.
So why not? I can put this domain as minus 4 pi to minus 2 pi. Why should I make it even like this? No, I will not.
Yeah. They don't do that. Yeah. That's why some of the domains are kind of weird. Some was 6 pi and like 2 pi. Not the normal ones that I usually see. So yeah.
Correct. Because what is our job as a teacher? To make you write well, right?
Yeah, that's true. Make us startled. Okay. Well, it worked. So
you can take a picture of this mess also.
Yeah. No, it's not messy. This is how my exam would look, no joke, when I come to it.
Good.
Perfect. Okay. So yeah, those are the 2 main questions. I think, it's really clear now in my head.
Very so that's good. So I think you have understood all these things. That's very good. Can you summarize your learnings now?
Yeah. So when I kind of started, I was trying to think about the parent functions only, and the whole restriction and domain part was kind of making me a bit puzzled. And like we discussed in the beginning, just about the wording about range and domain, because whenever we use range, we're talking about the y-axis, but in this one, it was just talking about the range within the domain.
Let me correct. Not in this one. 90% of your questions, not 90% of your questions, which comes in UK standard, whatever, they always flip with these terms. They will use range of the domain and they will only write kind of range, right? Many new immigrants, especially, they get highly confused and they don't get these questions right. No.
No, because they are quite highly marked. So I think it's a good point that you raised that. So just getting that, because this is not a maths issue, that's just the kind of technicality of the words that kind of gets a bit iffy. But so I kind of learned how to think about, so don't be so concentrated on domain as you begin. Try and just think about the parent function and then pick, you should have an idea, because all our previous lessons we discussed about the transformations. Have that in mind, whether the range does change or is it just horizontal shifts and translations, and then pick a point, and then like we saw, if we're trying to get in the domain, just subtract pi, because that's the interval between 2 points that cut the axes, and then just keep going until you get into the domain. So don't try and like think of points.
Required range of the domain.
Yeah, that's the wording.
Correct. Right. That is the key. Then only you get this question, as you were saying many times, they also put values like -6 pi to something like that. So then it becomes very difficult. So that is how you have to get your answer. Is that clear?
And it's a good thing you showed me like multiple methods with the coordinate stuff and also just graphing it, because you can't sometimes, if it was the coordinate one, you're not going to sit there doing up until 6 pi. Like you have to be realistic. Sometimes you have to just quickly do the graph method, which was so accurate but so quick. So
and one more thing was, you could start from anywhere. This is a periodic function. So because they wanted from -2 pi, and there was a shift of pi in our first example, why not start with -3 pi? I mean, why should I start with 0? I can start with -3 pi, get to -2 pi in the first step.
Don't try and wait to do it and then go back. You just want to do it in the one step. Don't try and do it like multiple steps. Because efficiency is key.
Because in the test, time is key. So you have to follow the best method, and you have to apply all these strategies which you have learned here. They help.
That's true.
Great, Amy. I think you have understood all these things. We'll end our class here for now.
Perfect. Thanks.
Have a great day. Thank you.
And you. Bye.
Bye.